In this video, we will see how to find the adjoint of a 2 by 2 matrix. I'm going to take you through a very slow step-by-step process, but at the end of it, I'll also show you a technique, a trick, how to get it done in a very short method. So kindly watch till the end of this video. So first of all, you need a square matrix to find the adjoint. So that's why we are trying to do for a 2 by 2 matrix here. So after you have the 2 by 2 matrix, you need to find the minor of that. Then once you have the minor of this matrix, then you get the cofactor of this matrix. And then you will find the transpose of this matrix. So let's go through the step-by-step process. So first we need to find the minor. All right. So let's consider this matrix A, B, C, D. It's a 2 by 2 matrix. So to find the minor of this matrix, we need to find the minor of each element. So for A, the minor would be remove the items which are in the same row and in the same column. So you are left with a D. So D is the minor of A. So minor of A is D, right? So next, what will be the minor of B? Remove the items which are in the same row and the same column. Now we are left with the C. So C is the minor of B. So minor of B is C. Similarly, for C, what would be the minor? Remove the items which are in the same row and column. So you're left with this B. So B is the minor of C. Minor of C is B. Alright. Then the last one is D. So eliminate the same items which are in the same row and column. You're left with A. So the minor of D would be A. Great. So let's put them in a matrix form. So this is our minor matrix. So you can see D is the minor of A. C is the minor of B. B is the minor of C. A is the minor of D. You'll also notice for a 2 by 2 matrix, they're nothing but the diagonal elements. The minor of A will be its diagonal element, which is this D. And for C, it will be the diagonal element, which is this B. So you just, change interchange them diagonally, then you get the minor. All right. So next, from the minor, we're going to get the cofactor. How do we get the cofactor? You multiply it, or you multiply each of the element with this sign table. I call this the sign table because it starts with a plus and it keeps alternating. So plus, minus, and then it is also alternating vertically. So plus, minus, minus, plus. So it's an alternating sign table, but it starts with a plus. So when I multiply each element with this table, D will be multiplied with plus, so it will be plus D. C will be multiplied with this minus, so it will be minus C. B will be multiplied with this minus and it will become minus B, and A will be multiplied with this plus and it will become a plus A. So we get the cofactors here. So let's put them down as a cofactor matrix. All right. So can you see D into plus is a plus D, C into minus is a minus C, B into minus is a minus B, A into plus is a plus A. All right. So now we have the cofactor. So from the cofactor, we have to find the transpose. The transpose is you take the elements in this row and make it as the elements of the column. Then that's your transpose matrix. So D minus C in the first row becomes D minus C in the first column. Minus B and A in the second row becomes minus B and A in the second column. That's so simple. Now this is our adjoint matrix of the matrix A, B, C, D. All right. Let's look at a real example. So we have 3, 1, 4, 2 as the matrix. So let's find the minors. So minor of 3 will be 2. Minor of 1 will be 4. Minor of 4 will be 1. And minor of 2 will be 3. So let's put them down as our matrix. This is a minor matrix. So from the minor matrix, we're going to multiply it with the plus minus minus plus sign. So 2 times plus will be a plus. 4 times minus will be a minus 4. 1 times minus will be a minus 1. 3 times plus will be plus 3. So we have the cofactor. Next, we need to do the transpose. So to do the transpose, 2 minus 4 will be the first column in our transpose matrix. So the row here becomes the column here. So 2 minus 4 will become 2 minus 4 in the column. And minus 1 and 3 in the second row will become minus 1 and 3 in the second column. So this is our adjoint matrix of this matrix. Now I'm going to show you a technique of how this is done so easily in a 2 by 2 matrix, and this works only for the 2 by 2 matrix. So when you have a 2 by 2 matrix, you don't have to go through this lengthy process of finding the minor, cofactor, and transpose. I will show you a very simple technique. So you have 3, 2. These are the diagonal elements, right? So these diagonal elements are interchanged. So 3 and 2 will become interchanged as 2 and 3. Simple, very simple. Diagonal elements are interchanged. Then the other elements in the table will be of opposite sign. If this is a plus 1 here, it will become a minus 1. If it's a plus 4 here, it becomes a minus 4. So the signs will be interchanged for the other elements. All right. So let's try and find for this. Can I give you a second to solve this? Yes, I'm sure you got the right answer. So you interchange 6 and 9, it becomes 9 and 6, right? And then you change the signs of 8 and 5. So it's minus 8 and minus 5. All right. So I give you one more to work out. Great. So our solution would be interchanging 7 and 2, 2 and 7, and changing the signs of 4 and 6, minus 6 and minus 4. Thank you for watching Math Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.